I recognise this. This is a weather balloon that's a very standard type, isn't it? Tell me about how these are used.
Yes, we use in EUMETSAT this type of balloon to make short missions. So we use it for a payload with the weight of the payload is between 2 kilograms to 4 kilograms. And the profile of this type of balloon is an ascent between 35 kilometers to 25 kilometers, yes. And the ascent is nearly 5 meters per second, the speed. And after the balloon bursts, and we have a descent under a parachute around 1 hour. And after we recovered the payload and parachute and something like this.
So it's very simple, isn't it? Because this balloon is very stretchy.
Yeah.
So as it goes up, it's carrying some instruments, but it gets bigger and bigger and bigger and bigger.
Yes.
And at some point, it gets so big that it bursts.
Yes. So at first, you have this volume is nearly 5 cubic meters, and the diameter is nearly 1.5 meter to 2 meters. Mm-hmm. And just at the moment when the balloon bursts, the diameter is around 10 meters.
So it would fill this space?
Yes,
if it
10
was
meters
full.
the diameter, yes. It's very big.
And then tell me about what it's carrying, because these are instruments that they're sending their location, but they're not sending data. So it's all carried.
Yes, it's
and then
carried.
you have to go and pick
yes.
it up.
We pick it up and we receive the data and we analyze the data. So the payload is often counterparticle for ozone or greenhouse gases. Mm-hmm. Or we use a radiometer to analyze it in infrared. It's really for science and for new instruments and really light instruments.
Yeah, so
yes.
it can only carry a small amount.
Yes, yes. Between the size is like this, yes, yeah. And the weight is, yes, maximum is 4 kilograms because you have to respect the international civil aviation rules. Mm-hmm. So it's 4 kilograms maximum and it's enough, yes.
In lots of places around the world, balloons just like this are sent up twice a day, all around. It's an amazing thought, isn't it? All around the world.
Yes.
And that data goes into weather models now.
Yes, it's true, yes.
But balloons get more sophisticated than this. So why don't you tell me about the one behind us here?
Yes, this one is really sophisticated. It's to track cyclone. With this one, we want to analyze the eyes of the cyclone. So we want to track one. So it's really difficult to have the good trajectory to find the cyclone.
Right, because these are very high winds. It's a very dramatic situation.
Yes.
This is actually very close to the water.
Yeah, it's very close to the water, around 10 meters above the sea, and we analyze data surface, yes, and the wind surface too.
So it's held. It's like a kite.
You have a rod, yes, like a kite surf. Yeah.
They don't use very much power, do they? They're very efficient and small and light. So they're better than an aircraft, for example.
Yes, it's better than an aircraft because you can go to the cyclones, yes, and to understand the influence of the surface in the boundary layer, and to understand the influence of the boundary layer in the cyclone.
As the balloons get bigger, the things that they carry get bigger as well. So what sort of things can they carry, the big balloons?
No, they carry a really small payload. It's nearly 30 kilograms, just 30 kilograms.
You've got some payloads,
No, I can show you another payload.
Let's have a look at the other one.
Okay, but it's not the same balloon. It's a zero pressure balloon, so it's really big balloon, and you can carry a payload. And the weight of the payload is around 1 ton. Okay.
So this is what would be hanging off the bottom of a very big balloon.
A very big balloon, yes.
And what weight could it carry?
They can carry a payload around 1 ton.
So it's huge.
Yes. The weight of the balloon for carry this is nearly 1 ton of polyethylene.
Right.
Yes. The resin is 15 micrometers.
Right.
At float, it's around 150 meters.
So a balloon that is 150 meters across, carrying that.
Yes.
That's a big balloon.
Yes, it's a big balloon. Yes.
But it works. It gets to places that people can't go.
Yeah.
So what have we got here?
Okay. Here, this is a fly change for this type of balloon. So we use just under the balloon this type of parachute, and the surface is between 2 to 3 meters.
So it's a very simple parachute.
Very simple. Oh yes, it's really simple. It's simple. It's a parachute for drone.
Oh.
So
okay.
yes, very simple one. It's a French one. And just between the balloon and the parachute, we put this. This is a separating system.
Yep.
Because we want to release the balloon when it bursts.
Yes.
You have piece of balloon, piece of latex.
Yeah.
So we don't want that.
So you have the.
So
once
we
it's burst,
cut.
Yeah.
And we use this.
Okay.
In
Yeah.
fact, it's very simple. You are like this. Okay.
Yeah.
And when the balloon bursts, we do this. Click.
Yeah.
Say clock. And after we cut here,
So
and
the
you
string
release
is
the balloon.
released.
Yes. Okay.
So-
it's really light. It's 100 grams, and it's for release the balloon.
So it's a really simple way of cutting a string.
Yes,
But
it's
it hasn't
a
got
cutting
scissors.
system.
Is it heat?
No.
How do
Yes,
it-
I see. Yes, it's the heat, but you can see.
So it heats
it's-
up and
it's-
melts
yes,
the string.
Yes.
So
You have
cut
something here, and here you have a small rope, and
Yeah.
we hit the small rope, and we open these two one.
And then
these
it
two
breaks.
pieces. Yes, and it releases. Okay.
So then these two bits.
Yes, this is very simple. It's a metal jigsaw.
Right.
Yeah. It's for tracking the balloon during the flight.
Yeah.
Just that.
So you can sit on the ground with a computer
Yes.
and you know.
You see. Yes.
and you can
where
see
is
where
it.
it's going on the map.
Yes.
So,
So
you
it's
can't control it,
just-
but you can.
Yes,
follow.
just to follow, just
Yeah.
to follow, and for the recovery.
Yeah.
Yes, and after for the recovery, we use this. It's system of tracking.
Oh.
Yes, we
okay.
use two systems: GSM, so like your phone, your mobile phone, and the other one is Iridium system.
Yep.
So you have
Sa-
two systems,
satellites,
satellites, yes,
yeah.
and it's really nice to use it when you have no GSM, no mobiles.
Right.
So you use the satellite systems, and it's for the recovery because sometimes the price of the payload
Right.
is nearly 10,000 of euro.
Really?
Yes.
So you want to get it back?
Yeah, we want, and the scientists too.
Right. So you have to drive out and just
we
use the
drive.
tracker
You
information.
use this tracker and your mobile phone.
and you look, don't you? Because I've done
Yes.
this. You're like, is it over there? Is it? You know, you sort of.
Yes.
It's somewhere within 100 meters.
Yeah, yeah. You
And we have to find it.
use your mobile phone with a map,
Yeah.
and you have the position in real time.
So it's like a treasure hunt.
Yes.
Yeah.
Yeah.
You get your weather data back,
Yeah.
and then you can take it and analyze it.
It's really nice to find the treasure.
Yeah.